This video is on finding partial derivatives. And let's just talk about, in general, the notation, and then we'll talk about actually finding the partial derivatives. So we're going to use this when we have functions of more than one variable. So in general, the partial derivative of f with, left off f, right? Of f with respect to x. All right, so the partial derivative of f with respect to x is denoted, either you'll see f with this little subscript x here, which means take the partial derivative of f with respect to x, or you might see it in the Leibniz notation, which in this case now we're going to use these like curly looking d's instead of a hard like regular d that we have on there when we're taking the derivative. Partial derivative, we use this curly d, so it's df dx, derivative of f with respect to x. Remember, f is a function that's going to be of several variables now. Right? So it's denoted like this and means take derivatives of f with respect to x and treat the other variables, in this case just y is what we're going to have, and treat y as a constant. So we don't act as if y is a variable anymore, we treat it as a constant if we're taking the partial derivative with respect to x. So it really is saying take derivatives with respect to x, and anything else that's not an x you treat as a constant. I'm calling it y here, but it could be other variables. Similarly, if we had f with a little subscript of y, or in the Leibniz notation df dy with those curly d's, this means take derivatives of f with respect to y and treat all other variables, in this case I'll just call it x, and treat x as a constant. So when you see these, it really means treat just that variable you see as a variable, and the rest of the variables you'll use as constants in the problem, or treat them as constants as you take the derivatives. So we're going to do an example. I think this is the easiest way to kind of see this. But these are partial derivatives with respect to x. These are partial derivatives with respect to y. And as we do this, you'll be asked to find both. So if I said given, for this example here, if we say given f of x comma y equals x squared y to the third plus xy plus 4y squared. Alright, we're going to say find. We'll find the following. So for the first one, a, let's say the derivative of f with respect to x. Right, so I wrote it in Leibniz notation there, and that, make sure you know what it means, right? So the partial derivative of f with respect to x. That's why we have the curly d there. So how do we do it? Well, we have to look at each of the terms individually. Remember, you're treating x as a variable and you're treating y as a constant. So because it's with respect to x, x is a variable, y is our constant. So in this first term, we have x squared times y to the third. Remember what this is really telling me, right? X squared times y to the third, I have y to the third is a constant times a function. So when you took a derivative of a constant times a function, you kept the constant part the same, and you just took the derivative of the function. So the y to the third is going to stay, and you have the derivative of x squared using our derivative rule says bring 2 down in front. Make that x to the reduced power 1 by the first power. Then y to the third is a constant times a function just stays there. Plus the next term, the derivative of x times y. Well, what's the variable, what's the constant? Well, the variable is x, because we don't respect to x. The constant is y, so the constant always stays. When you have a constant times a function, you take the derivative of the function. The derivative of the function x is just going to be 1, right, times the constant y. Plus, for the last term, we have 4y squared. Well, 4 is a constant. Y squared, that's also a constant, right? There are no x's here, so there's no variable. So the derivative of a constant, this whole thing is a constant. Derivative of a constant is always 0. Now, you don't necessarily have to write it. I'm writing it there, though, so you can see it. And now we just simplify. So you have 2x y to the third plus 1 times y is just y. And then plus 0 you don't need. So 2x y to the third plus y would be the partial derivative of f with respect to x. All right, remember, you're always treating whatever you're taking the derivative with respect to, that part's the variable, and everything else is the constant. Suppose I asked you this. If we're taking the partial derivative of f with respect to y. Well, now as I do this, remember what we're doing. We're treating y as the variable, and x will be treated as a constant. So we have the first term, x squared y to the third. X squared, is that a constant or a function? Well, since with respect to y, the x squared is a constant, so it's a constant times y to the third. Well, that's a function because it has y's in it. So if we have a constant times a function, the constant stays, so the x squared is going to stay, and then you take the derivative of the function. So it's going to be x squared times the derivative of the function, the y to the third, becomes 3y squared. And that's the derivative of the first term with respect to y. Plus, here we got x times y. Well, x, again, that's a constant, right? Because the function that we're looking at has to have y, so it's a constant times y is the function here. So the constant stays, and you take the derivative of the function. The derivative of y, well, that's just 1, so it's x times 1. Plus the derivative of the last term, 4y squared. Now, 4 is a constant, but it's times this function y squared. Well, how do you take the derivative of y squared? You're going to bring the 2 down, so 2 times 4 makes this 8, and then y to the first power. And then we'll just simplify what we have. So this gives us x squared times 3y squared is 3x squared y squared, plus x times 1 is just plus x, plus here we have 8y. Alright, so depending on what you're taking the partial derivative with respect to, it changes how you approach the problem. Sometimes you'll be asked to substitute into the partial derivative. If I had the partial derivative of f with respect to y, and you'll see this bar here sometimes with an ordered pair. Here I'll write 1, 3. What that really is asking me to do is it's saying, alright, substitute in 1, 3 into this partial derivative. So you always have to take the partial derivative first. We already did, right? The partial derivative of f with respect to y, we did it right here. But if you hadn't done this, you'd have to do that first. Then you can substitute in 1, 3. Remember, you're substituting the x value of 1, so this will be 3 times 1 squared. The y value is 3, so times 3 squared plus x, which is plus 1, plus 8 times y, so this is 8 times, we've got 3 here for y. Just substituting in. And then you want to evaluate this. Looking at this, 3 times 1 squared times 3 squared. 3 squared is 9 times 1 squared. Well, that's going to be times 1 times 3, so it's going to give me 27. Plus here we got 1 is just plus 1, plus 8 times 3 is 24. And adding those together, 27 plus 1, I'll give you 28. 28 plus 24 gives us 52. So 52 would be the partial derivative of f with respect to y, evaluated at the point 1, 3. And that's all that's showing. Alright, let's take a look at another one. This takes practice. If you don't practice this, you probably won't understand how to do it. For this example here, if I said given f of x comma y equals the square root of x squared minus y squared. Find, and we'll go through and find different partial derivatives. So if I said f with this little x down here, subscript x, that means take the first partial derivative of f with respect to x. So before I can take derivatives here, make sure you remember what we did. If I have a square root in here, I'm going to take derivative of this. First thing I should do is rewrite. You remember how you rewrite a square root? The x squared minus y squared is going to be on the inside of here. How do I rewrite the square root as a power? Well, power in this is 1 over whatever the index of the root is. So in this case, square root has an index of 2. So I'm rewriting it as x squared minus y squared to the 1/2 power. Once I've done that, I'm ready to take this partial derivative with respect to x. So remember what that means. The x's are treated as variables, as functions, and the y's are going to be constants. So when I'm taking the derivative of this, I got x squared minus y squared all to the 1/2. Well, what do you have to use? Well, this is a function inside of a function. You have to use the chain rule. So how do you take the derivative here? You bring the 1/2 down in front. So we'll have 1/2 times, you leave the inside the same. Remember, this is how chain rule works. So take the derivative of outside, keep the inside the same. Subtract 1 from the exponent makes this negative 1/2, right? 1/2 minus 1 makes it negative 1/2, times the derivative of the inside. Remember, with respect to x here. So the derivative of x squared, well, that's a function. So the derivative of x squared, that's going to be times 2x, minus, what's the derivative of y squared? Well, the derivative of y squared, y is a constant right now. So it's really going to be minus 0. Maybe I'll write the minus 0 there just so you see that I acknowledged it. But you don't necessarily have to have it, right? The derivative of y squared is just going to be 0 because y squared is a constant. Because we're taking derivatives with respect to x, we treat y as a constant. And then you should simplify this, recognizing that, you know, the negative exponent is going to bring it to the denominator, and this is times 2x minus 0. So you'd have 2x over 2 times the negative exponent, bring this down, would be x squared minus y squared to the 1/2 power. And then we'll simplify this. The 2's will cancel out, and you're left with, we have x over 1/2 power is the square root of x squared minus y squared. You don't need to rationalize this. You can leave it as that. All right, so that's the first order partial derivative of f with respect to x. Let's take a look at the partial derivative of f with respect to y. So you're taking the derivative here, right? It's rewritten already, so we're already where we need to be. We have a function inside of a function, right? We have this x squared minus y squared being raised to the 1/2. So again, you need to use chain rule. This time though, y is the pieces that are being used as functions, and the x's are treated as constants. So the 1/2 will come down in front. The inside stays the same. That's what chain rule says to do. So x squared minus y squared. We're raising this to, remember, 1/2 minus 1 power makes it negative 1/2, times the derivative of the inside. Well, the derivative of the inside of this, right, x squared, well, x squared, that, right, this is with respect to y, so x is a constant. So this is a constant, x squared is a constant, derivative of a constant goes to 0, so it'll be 0 minus the derivative of y squared. Well, that's the variable we're taking it with respect to, so the derivative of y squared as a function, this becomes minus 2y. Right, so that's the derivative of the inside. And now that's it. We did chain rule. Now we're just ready to simplify. To simplify this, maybe we can do it without showing everything. 0 minus 2y is a negative 2y. The negative 2 and that 2 are going to cancel, so it's going to be a negative 1 in front, or just negative. You'll have a negative, these 2's cancel, and then you have y, so negative y. Over in the denominator, you've got this x squared minus y squared to the negative 1/2 is the square root of x squared minus y squared. And that's just me simplifying this. If you need to show it, make sure you show it. You'll have 2y over 2 times the x squared minus y squared to the 1/2, and then the 2's would cancel. You're rewriting it as a square root. So it is different. They are not the same. You have to make sure you're paying attention to which variable you're taking the derivative with respect to. And then if I said to find the partial derivative of x evaluated at negative 2, 1. Well, remember what's going on here. First, you have to take the partial derivative with respect to x. We already did it. If you hadn't already done it, you would have to do it. And we have it up here. It's for x over the square root of x squared minus y squared. We're going to substitute in. Remember, this is an x value and a y value. So summing in for x, we'd have negative 2 over the square root of x squared is negative 2. Make sure that quantity is squared. Minus y squared, so minus 1 squared. Make sure you realize that minus isn't getting squared, just the 1 is. And then we'll simplify. We end up with, this is negative 2 over, this is the square root of, this would be negative 2 squared is 4 minus 1 squared is 1. 4 minus 1 is over 3. And if you wanted to rationalize, I'm okay if you don't rationalize, but if you wanted to rationalize this, multiply by the square root of 3 times the square root of 3. You end up with negative 2 square root of 3 over square root of 3 times square root of 3 is just 3, so you got negative 2 radical 3 over 3. I would accept either of these answers. They are equivalent, and I'm okay with you not rationalizing your solutions. Let's take a look at another example. So, you know, all the rules that we've already learned, chain rule, product rule, quotient rule, all those still apply as we go through this. So for the next example here, if I said we're given f of xy equals e to the 3x minus 2y power. All right, we're looking for the partial derivative. So I'll say find, for the first one, the partial derivative of f with respect to x. Well, this is e to a power, and remember how we handle derivatives of e. Derivatives of e, we write exactly what we see. So we're going to write e to the 3x minus 2y multiplied by the derivative of the exponent. This is the chain rule for e, is what we're really doing. So derivatives of e, write exactly what you see, times the derivative of the exponent. Remember, this is with respect to x, so the derivative of 3x will be times 3 minus 2y. Well, y is a constant now, so this whole thing is a constant. The derivative of a constant always goes to 0, so this is just going to be times 3. So simplifying this, you have 3e to the 3x minus 2y. And that's the partial derivative of f with respect to x. For this next one, if I said partial derivative with respect to y, well, again, derivatives of e, you write exactly what you see. So you write e to the 3x minus 2y times the derivative of the exponent, right? This is chain rule for e. The derivative of the exponent with respect to y, that means anything with the x is a constant. So 3x is a constant, so the derivative of that would be 0. The derivative of negative 2y, well, y is a function. Derivative of negative 2y, well, it's going to be negative 2. So we have e to the 3x minus 2y times the derivative of the exponent, which is just negative 2. And so simplifying this, it's negative 2e to the 3x minus 2y. And you leave it at that. Let's take a look at a couple more. Alright, so that was chain rule with e. This next one, if I said given f of x comma y equals y times natural log of xy. And we'll say find, and the first one we'll do is, again, f with respect to x. Make sure you are looking, though, you give the correct answers, or looking for the correct thing. So, first order partial derivative of f with respect to x. Take a look at what's going on here. We got y times natural log of xy. Now, it's important to know, you know, when I'm looking at this, if this is a constant or a function. So we have some things that are being multiplied. What's being multiplied, though? Well, y, is that a constant or a function? Well, if we're taking derivatives with respect to x, the y is a constant. So this is a constant times natural log of xy. Is that a function or a constant? Well, it's a function because it has an x in it, right? The y is a constant, but the x is a variable, so this becomes a function. So This is really a constant times a function when we're doing this with respect to x. So how do you take the derivative of a constant times a function? Well, you leave the constant in front, so you keep y times the derivative of the function. Well, what's the derivative of natural log of xy? Well, this is going to be chain rule on natural log. So you would have the derivatives of log, or natural log, are 1 over whatever's on the inside, so 1 over xy, times the derivative of the inside. This is chain rule on natural log. Well, the derivative of the inside, we have x, which is a variable, right? So it's a function times y, which is a constant. So the y is going to stay, and the derivative of x is just 1, so it's going to be times 1y. So this y in front was a constant times the derivative of, right, this whole piece here is the derivative of natural log of xy. It's 1 over the inside times the derivative of the inside, with respect to x in this case. So then we want to simplify this. Well, how's this simplify? I end up with, we've got y times 1y. So one of these y's will cancel with the y in the denominator. And I'm left with 1 times 1y, which is just y over x. And that simplifies there. All right. For the first order derivative with respect to, oh, this should be y, sorry. All right, so the first order derivative with respect to y, well, how do we handle that? Well, let's take a look at what we've got. We're looking up here and we see, all right, we have y times natural log of xy, and we have to ask ourselves, are these functions or constants? Well, y times natural log of xy. Well, y, this is a function, right? Because we have a variable here, y, so that's a function times natural log of xy. Well, this is also a function because it has a variable inside. So when you have a function times a function, remember how we handle this. This is going to be product rule. Make sure you know this. Right, the first one wasn't because we did with respect to x, so this wasn't a function, but with respect to y, this is a function. So a function times a function, we use product rule. So remember how this works. This would be what we called f. This is what we would call g if we're using product rule, not the same f as we have here. But just remember how product rule works. You take the derivative of the first, so the derivative of y with respect to y, so the derivative of y would just be 1 times, we leave the second alone, so derivative of the first times the second, plus, it's the derivative of the second. Well, derivative of natural log of xy with respect to y, well, derivatives of natural log are always 1 over the argument, so 1 over xy, right, so 1 over the inside, times the derivative of the inside, the derivative of xy with respect to y. Well, x is a constant, y is a function, so the constant stays, so times x, and then the derivative of y would just be 1, so x times 1, right? The constant times the derivative of the function. So that's the derivative of the inside. And then you have to multiply for product rule, remember, times the original first. So times y. In other words, this, according to how we labeled this here, right? The derivative of the first times the second plus the derivative of the second, the g prime, times this is the first. So within the product rule, we had a chain rule going on, and that's okay. That happens, right? It's something we have to handle. And then we just want to simplify this. So 1 times natural log of xy is natural log of xy. Plus here, simplifying this, the x's will cancel and the y's are cancel. So you're just going to get plus 1 times 1, which is plus 1. So natural log of xy plus 1 is our simplified answer here. Let's just take a look at a few more. So if I said we were given f of xy equals 4 times, in parentheses, 3x plus 2y. Oh, there you go. So given f of xy equals 4 times 3x plus 2y minus 8 raised to the 5th power. We'll say find, same thing we've been finding, the first derivative, right? So this will be part A. First derivative with respect to x. Right? So first derivative of f with respect to x. And again, you got to think about what you've got here. You got 4 times 3x plus 2y minus 8. 4 is a constant times, this is going to be a function, right, even because it has an x inside of here. You know, it's a function inside of a function. It's really a function being raised to a power, so this is going to be a chain rule. Remember how you take derivatives using the chain rule, right? So it's the derivative of the outside, so the 5 is going to come down. 5 times 4 would make this 20, times you leave the inside the same, so this would stay 3x plus 2y minus 8, and then the power gets reduced by 1, so to the 4th power. And then you multiply by the derivative of the inside. Well, what's the derivative of the inside of here? With respect to x. Well, the derivative with respect to x of 3x, well, that's going to be just 3, right? This 3 stays in front. Derivative of x is 1, so it's just 3. Plus, what's the derivative of 2y? Well, y, remember, this is a function or a constant. It's a constant, because the derivatives are with respect to x. So y is a constant, so 2y is a constant. Derivative of a constant is always 0. And then minus 8, that's also a constant. Derivative of a constant is 0. So times 3 plus 0 minus 0. So that's chain rule, right? Derivative of the outside, brought the 5 down, left the inside the same, subtracted 1 from the exponent, times the derivative of the inside. And now all we do is simplify. Simplifying this is 3 plus 0 minus 0, so that's 3 times this. 3 times 20 would give me 60, times 3x plus 2y minus 8 raised to the 4th power. Don't lose that exponent there. And that's it. You can't distribute the 60 into here because of the exponent of 4 on the outside. Make sure you know that. If we took the derivative of f with respect to y, well, let's talk about what that would look like. It starts off the same type of way, right? This is a constant times a function because there's y in there. The constant stays in front. This is a function raised to a power, so it's going to be a chain rule for that polynomial. We're going to bring the 5 down in front, so 5 times 4, that gives me 20, times, remember, chain rule means you keep the inside the same, so you have 3x plus 2y minus 8. That's to the 4th power, right? Reducing the exponent by 1. Then you have to multiply by the derivative of the inside with respect to y. The derivative of 3x, well, x is a constant now because we're doing derivatives with respect to y, so 3x is a constant. The derivative of a constant is 0. Plus the derivative of 2y, well, if you're looking at this with respect to y, that's a function. So the derivative of 2y, the 2 stays in front. The derivative of y is 1, so just plus 2, right? Because 2 times 1 is 2. Minus the derivative of 8. 8's a constant. Derivative of a constant goes to 0. So that's chain rule, right? Derivative of the outside, brought the 5 down. You kept the inside the same. Subtracted 1 from the exponent. Multiplying by the derivative of the inside, remember, with respect to y. And then we'll simplify this in a similar way we did before. 0 plus 2 minus 0 is going to be 2. 2 times the 20 would be 40 times 3x plus 2y minus 8. This is to the 4th power, just using that there. Again, you can't distribute through, so you would leave it like that. All right, and let's take a look at one more here. So if I said we are given f of x comma y is equal to e to the xy plus y natural log of x. And we'll say find the first one. I'll say find the first order partial derivative of f with respect to x. Remember, that means you treat x's as functions and y's as constants. So taking the derivative with respect to x, we got e to the xy. That's a function because it has an x in there. Taking the derivative of this, derivatives of e, you write exactly what you see for the first term. So we got e to the xy, and you multiply, because remember, this is chain rule on e, times the derivative of the exponent. What's the derivative of xy? Well, x is a function, y is a constant, because we're doing it with respect to x. So the y is going to stay. The derivative of x is just 1, so it's times 1y. You just write it as times y, but I want to make sure you see it. Plus, we have y natural log of x. Well, this is a product, but it's a constant, right? Y is a constant times a function. So for a constant times a function, the constant will stay in front, so y will stay in front, times the derivative of the function. The derivative of natural log of x is just 1 over x. So then what does this equal? Well, simplifying this, e to the xy times 1y will just be y e to the xy, plus here y times 1 over x, so it'll just be y over x, and you leave it like that. There's really nothing that you need to do to simplify that. For b, if I said derivative of f, first order partial derivative of f with respect to y, remember this means y's are going to be functions. Anything that has x in it only will just be a constant. The first term, e to the xy, well again this is going to be a function because it's a function that has y in there. So e to the xy is a function, the derivative of a function of e. You write exactly what you see, so you have e to the xy times the derivative of the exponent. X is a constant, y is a function, so x is going to stay, times the derivative of y, which is times 1, plus, now here we got y natural log of x. Well, remember, y is a function, x is a constant, so natural log of x is actually a constant, and then you just want to take the derivative of the function piece. So the constant stays, the derivative of the function, derivative of y is just going to be 1 times natural log of x is just a constant, so it just stays, so times natural log of x. So it's important to know you're not doing a product rule on here because these are functions of different variables. If this also had y's in it, then you'd be doing a product rule on this. You couldn't just pick the pieces apart. So once you've done this, all right, this will be equal to e to the xy times x times 1 is just x e to the xy, plus here we've got 1 times natural log of x is just natural log of x, and then we leave it at that. And we'll look at, if I said the first order partial derivative of f with respect to y, and I'll say evaluated at 1, 3. So you might see it written like that. You might see it fy with parentheses and then 1, 3. They mean the same thing. I'm subbing in 1 for x and 3 for y into the first partial derivative with respect to y. If you didn't do this yet and they showed you this, you'd have to do this part first, then substitute in. All right, you never substitute in the point first. So x is 1, so we'd have 1 times e to the xy, so it would be 1 times 3 power, plus the natural log of 1. And making sure you know what you get here. 1 times e to the 1 times 3 power is just e to the third power, plus natural log of 1. Well, what's that? Well, that's plus 0. So this would equal e to the third power. And that would be, you know, the exact answer. You should leave it like that. So that was, you know, our derivative on, that was our video on first order partial derivatives. The next video, which continues on for this section, we'll have to do with second order partial derivatives. And it's not really that different, but, you know, it is something that you do have to take the time to make sure you learn.